This is DHCP1. The purpose of this network is to demonstrate the configuration of and use of DHCP. Now on this network, first we have the server out here, www.fastnet.com, which we're going to access using the DNS server. The address of the DNS server will be configured automatically with the DHCP configuration provided to these clients from the router R0. Here we have our configuration of router R0. We're going to exclude addresses .129 through .133. They would be used for any devices that need a static address. Our pool is going to be ABCDEFG. The name of the pool is not significant. Our network, when we specify the network right here, we give the address space with the subnet, and this tells us that we have 62 usable host addresses because it's a .192 or a /26. Our default router will be .129, the first usable host in this network, and the DNS server will be .130, the second usable host. And notice both of these addresses are in this excluded address space. Okay, now let's assemble this network. At this point, I want to make a note. This was incorrectly configured as 10.0.0.129. It is now corrected as 10.1.1.129. Please make sure you make that correction if you've already written down the configuration of the router. Okay, now our network is assembled. We've pasted in our commands into the router. Check for errors. We'll hit the fast forward button so our spanning tree has finished its work. Good. Now let's check our host machines and see if they have received their IP configuration. They defaulted to static routing, so we'll hit the DHCP button and we see that it receives its IP address, mask, the default gateway, and the DNS server. Let's check PC1. Successfully configured. It gets the next available address, 135. We see the PC0 got 134. And let's look at PC2, 136. The reason they're in order is because that's the order in which we change them from static to DHCP. We need to configure our DNS server. Go to the DNS service. It's turned on. Fastnet.com is at 209.165.100.10. We'll add that A record, and now our DNS is configured for fastnet.com. Now let's make sure we can ping that server. Okay, that's ARP doing its work. That request timeout. And make sure PC1 as well. Keep this on top. And PC2. Okay, now let's make sure we can all get to the server using the DNS service, our local DNS service. Okay. There. Now for this last one, we'll use the simulator and we'll capture DNS. Go. And we'll look in this packet and look at its inbound its source is .136, but its destination is 130, which is our DNS server. And we know that this is a DNS packet because the destination port is port 53. Notice the source port used by the PC was 1025. That's the first available source port available that most PCs use here in Packet Tracer. Okay, let's continue. Oh, and here's the name that it's looking for, fastnet.com. It's looking to resolve that name. So it goes to the DNS server. And on the way back, if we look at this packet, both inbound and outbound will be the same because it's just a switch. We see again the source IP address is the DNS server. The destination IP address is the host, 136. And the source port is 53 now. That's the server responding. And 1025 is the destination port. That's the port assigned by the originating PC. And if we look at our DNS message, again, we see that the name being resolved is fastnet.com. And we look at the answer. And the answer is 209.165.100.10. And now the packet will go out the router to the site and back. We'll just go to real time, go to the PC, and here we have it. Now let's look at our show commands, show IP DHCP binding and show IP DHCP pool on router R0. Show IP DHCP binding. And we can see that it gives us a mapping of our IP addresses to these MAC addresses. We've seen this before, something that's very similar to this. Almost identical to ARP. Only the ARP cache carries a lot more information than just what is carried in the DHCP binding. All right, now let's get our DHCP pool statistics. Show IP DHCP pool. And it tells us that we have 3 leased, 1 is excluded, 62 total. I'm not sure why only 1 is excluded. Show run, we excluded in our DHCP configuration 5 addresses. And it's only showing that 1 is excluded. I'm not sure why. Okay, your job now is first of all consider these 2 questions. If the general rule is that outside has no knowledge of the inside addressing, why is network address translation not needed in this network? And number 2, question 2, what changes would be needed if the DNS server was addressed to be on a different local area network while being connected to switch S0? In other words, what if the DNS server had address 10.1.1.200/26? All right, so keep these 2 questions in mind and have a great time building this network.